Okay, today we're talking about problems using sinusoidal models, and the most popular one is the Ferris wheel. So in this case, a Ferris wheel has a diameter of 16 meters and starts 1 meter above the ground. It takes 3 minutes to complete one revolution. So this is all the information that we were given. Now we have to determine the period, the amplitude, the axis of the curve, and sketch the graph of the height of the rider versus the time. So we know that x will be the time and y would be the height in meters, time in minutes. Okay, so let's determine first of all, the period. So the period is actually given to us because it takes 3 minutes to complete one revolution, which means the period is 3 minutes. Amplitude, well, how do we find the amplitude? We have to find the axis of the curve first. So we're going to find y first. We're going to say y is max plus min over 2. And then what is the minimum? Well, the minimum we know that it's 1 meter. So 1 plus. Well, the maximum, if the Ferris wheel starts at 1 and has a diameter of 16, that means that 1 plus 16, the maximum will be 17. So 1 plus 17 is 18 over 2. That means y equals 9. So my equation of the axis is y equals 9. My period is 3. So now I need to find my amplitude, which I know it's C minus, no, max equals C plus A, which means A, if I move the C over, so the maximum is 17, C is 9, because C is the equation of the axis. So I move the 9 over, A equals 17 minus 9, which equals 8. So I found all these information, so now I have to sketch the graph. Well, it takes 3 minutes to complete one revolution. So first of all, we need to put the scale on the height. So I'm going to pick the scale as 5. So every 2 squares will be 5, so that I have enough for 17. And my maximum, so this is 17.5, so 17 will be literally right under the line. This is my max. My minimum will be 1, so this is 2.5, which means 1 will be a little bit less than halfway through. This will be my minimum. And my equation of the axis is below 10, which is right here. So these are the 3 lines that we start with. And now I have to put the scale on the x-axis. So because I only have 3 minutes, I'm going to try and spread it as much as I can. So I'm going to say maybe, let me count. Okay, so essentially I picked every 8 squares, I'm going to have 1 minute. So 1, 2, 3. So my one cycle will end right here at 3. So where do I start from? Well, I start from the bottom because you need to load at the bottom. Now the question is, where is my peak? Well, the Ferris wheel, we all know it's round, right? So if I start here and my peak is here, that means it's halfway through. So at 1 minute and a half, so 1, 2, 3, 4, this will be 1 minute and a half, I will have my peak. So my graph is going to come up gradually, going to reach the peak, and then it's going to slowly go down, and it's going to start again, and so on. So this is my graph. Now we're going to use the period amplitude axis of the curve and phase shift from the graph to determine an equation. So we already have the period, but to be able to write down an equation, I need the value of k. So 3 equals 360 over absolute value of k, which means absolute value of k equals 360 divided by 3. So absolute value of k equals 120. We'll decide later whether k is positive or negative. So this is my k. I have my c, which is 9. I have my a, which is 8. And now I have to decide whether I'm going to use sine or cosine. So if I look at the graph, it starts at the trough. So probably the easiest way would be to do a cosine with a reflection in the x-axis. So y equals a cosine of k x minus d plus c. And choosing cosine with a reflection will basically get rid of this d value. So y equals, so a is actually negative 8 because we decided to have a reflection. So negative 8 cosine, k is 120, so 120x, I don't have a d, and then plus 9. And this will be one of my equations for this graph. I can also do a cosine with a shift. So without the reflection, I can move this point here, which means it's going to be minus 1.5. So d will be minus 1.5. Or I can even, sine would be a little bit more tricky in this case because I have to find out what this point is, so I can move it here. So cosine would be probably the best choice in this case. So now we need to use your equation to determine the height of the rider for 4 minutes and 12 minutes. So essentially x is 4 minutes and x is 12 minutes. So all I have to do is plug it into the equation, negative 8 cosine of 120 times 4 plus 9, which equals 13. So it's 13 meters. And then y equals negative 8 cosine of 120 times 12 plus 9, which equals 1. So essentially after 12 minutes, the Ferris wheel will be back to the trough. Okay, so this is the first example. We're going to go to the second one. It's about an ice cream company that tracked its mean monthly production of ice cream over the last 2 years. So as you can see, January, February, March, April, so the entire all 12 months. And then the production in thousands of liters. So it starts with 168, and then it goes up, 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 up. This looks like it's the peak, and then it goes down, 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 and then it starts again, up, 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 peak, down, 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 down. Okay, so first of all, explain why it is reasonable to expect ice cream production to be periodic. Well, how much ice cream do you eat in January compared to July? A lot more. When it's hot outside, we eat more cold things like ice cream. So in the winter months, the production is low, but as it gets warmer, it starts to pick up, and then July or June is the highest, and then it starts to slowly drop. So why it is reasonable to expect production to be periodic? Because during the winter months, there is not much demand for ice cream, but as the weather gets warmer, demand increases, which means production increases. Okay, so we need to determine a trigonometric model that best represents the data. Okay, so on the x-axis we will have the time, so the timeline, which is months, and on the y-axis we will have the production. I'm just going to write production in thousands of liters. Okay, so I see here that the maximum is 276 and the minimum of, it looks like it's 168. So I'm going to take these two numbers. I'm going to just break this one here, and I'm going to actually start at 168, and I'm going to go every square 20 units, 20,000 liters. So 188, 208, 228, 248, 268, and 288. Okay, and then I'm going to just plot these points. So January will be the first month, and then I'm going to have January, February, March, April, May, June, July, August, September, October, November, December. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I didn't miss any. Okay, so it starts here. January is basically the origin because that's the starting point. So I'm going to plot the first year. So 168 will be in January, 181 in February, 219 in March, then 222 in April, then I have 246 is right here in May. June is 276, so I go all the way here. Then I have 264, so it drops here. And then I have 252 in August, so 252 will be here. And then I have 219, which is here. And then I have 204, which is below 208. And then I have 181, which is here. And then I have 174, which is here. And then it starts again with January 169. So I'm just going to plot this one here. 180, 219, 220, sorry, 221. So essentially the points are almost the same. It's just 1,000 meters more. So it looks like a pattern, so I'm going to just draw the curve of best fit. This seems to be my peak, and it goes down. and then it goes up again. Okay. So let's write the equation of this graph. So I'm going to say my minimum is 168 and my maximum is 276. So I'm going to do it algebraically. So I know that y equals max plus min over 2. So y equals 168 plus 276 over 2. Which equals 222. So this is my equation of the axis, 222, which is right here. Okay, equals 222. My amplitude equals max minus C value. So amplitude equals 276 minus 222, which is 54. So my A is 54. My period, so P, equals 12 months, which means my K value, so 12 equals 360 divided by absolute value of K, so absolute value of K equals 360 divided by 12, which is 30. We're going to decide later whether K is positive or negative. And then we have to decide what are we going to do. Are we going to do sine or cosine? So the easiest would be, of course, cosine because it starts at the trough. So cosine with a reflection in the x-axis. So I will have y equals A will be negative 54. Cosine of K is 30x. I have no shift because it's already on the y-axis. And then plus 2, 2, 2. And this will be my equation for this graph. The homework is at the bottom. And that's it.